the immensity of the universe. In this lesson, we're talking about solar systems, galaxies, the Andromeda Galaxy, aliens, and the Drake equation. Think about it. So I'd like you to pause the video and answer questions number 1 and 2. First of all, what is the definition of an alien? And number 2, if a child were born on Mars, would it be considered an alien? So the way that we describe our objects in space is that solar systems are big, galaxies are bigger, and the universe is the biggest. I'd like you to pause the video and check out number 1. It gives you a really good perspective on the size of the universe. Solar system. A solar system is made up of all the planets, moons, comets, and asteroids that orbit a star. So for example, our solar system consists of 1 star, 8 planets, dwarf planets, more than 200 moons, and millions of asteroids and comets. Everything inside this picture, as well as many things that aren't in this picture, are inside our solar system. A galaxy is a group of stars, most with their own solar systems. So for example, our galaxy is called the Milky Way galaxy, and there are between 100 and 300 billion stars in the Milky Way galaxy, and many of those stars will have their own system of planets and moons. The nearest galaxy to the Milky Way is the Andromeda Galaxy. It would take light traveling at 300,000 kilometers per second, the speed of light, about 2.7 million years to reach it. It would take about 155 billion years to travel there using our current technology. It's not really a place that's reachable for us with our current understanding of physics and space travel. If you take a look at this picture on the right-hand side, that's the ultraviolet side of the Andromeda Galaxy as captured by NASA's Galaxy Evolution Explorer. So it's taking the ultraviolet light and making a picture out of it. There are approximately 200 billion galaxies in the universe. Each galaxy will have about 300 billion stars, and then many of those stars, like we talked about, will have their own system of planets, moons, asteroids, etc. So are we alone? Write down what you think based on what you've learned so far. Do you think we're alone in the universe? Explain your answer. Before coming to your answer, I want you to think about how many stars there are, and then how many planets there could be as a result of the number of stars. Just think about the sheer number and the possibilities they bring out. So pause the video and answer this question. So let's do the math. 200 billion galaxies times 300 billion stars per galaxy gives us this number of stars in the universe, each with their own planets and moons. That's a lot of possibilities. One thing that people lose perspective on is that when they look up in space, all these little dots of light, every single one of them, the bright ones, the not so bright ones, those are all stars. And each one of those stars contains possibilities for life. Even areas that appear black, if you were to zoom in further and further and further, would contain stars. There's just such an immense number of possibilities out there. It's mind-boggling. So with that many planets and moons, it's hard to believe that aliens don't exist. At least I think they do, just simply based on the math involved. And that brings us to the Drake equation. Now the Drake equation is used to calculate the odds of intelligent life. So what I'd like you to do is pause the video and watch number 2. It's a pretty good little take on what the Drake equation is. After you watch it, come back and we'll go through each step one by one. So N is a number of communicating civilizations in the galaxy. R represents a number of stars in the Milky Way galaxy. So the current estimates are around 100 billion. That's on the low side because 100 billion to 300 billion. FP is the fraction of stars that have planets around them. So we can estimate that between 20 and 40%. NE is the number of planets per star that are capable of sustaining life. So we look at our solar system, that's about 33%. FL, on what percentage of planets that are capable of sustaining life does life actually occur? Current estimates range from 100%, like ours, down to almost 0%, because maybe we're the only one that has ever evolved life. We're not sure. Fi is the fraction of FL where intelligent life evolves, and again that can range from everywhere from 100% down to close to 0. FC is the fraction of Fi that will communicate, and we can estimate that to be about 10 to 20%. And F capital L is the fraction of the planet's life during which the communication civilizations live. Now this is a really tough question. If we take Earth as an example, the expected lifetime of our Sun and Earth is roughly 10 billion years. So far we've been communicating with radio waves for less than 100. How long will our civilization survive? If we survive for another 10,000 years, the answer will be 1/1,000,000th. So that would be the fraction that you'd put in. And then you get your answer for N. Now, if we use some conservative numbers, this is what we'll get. About 1.32 civilizations per galaxy. Now, that's using conservative numbers again, and again, that's per galaxy. We said there's close to 200 billion galaxies. So to find the total number of communicating civilizations right now, potentially what you would do is take 1.32 and multiply it by 200 billion, which comes out to be 264 billion communicating civilizations in the universe. Again, that's a very rough estimate, but if we bring our numbers down even further, you can see that that number of communicating civilizations still hovers in the millions to billions mark. So it's really hard to believe that we are the only ones, in my opinion. Now, if you want to throw some different numbers in, take a look at number 3. It's a Drake equation calculator that you can use to figure out the number of communicating civilizations given different numbers. However, you do need to keep in mind you can't go too much lower than these because, of course, there is at least one communicating civilization in the Milky Way galaxy. So let's reiterate our findings. If N equals 1.32, that means there are 1.32 civilizations capable of communicating within the Milky Way galaxy using our very conservative numbers. The number of galaxies thought to exist in the universe is about 200 billion, like we said, And then again, if we put them together, we multiply 200 billion times 1.32, we get 264 billion communicating civilizations, potentially, in the universe. This thought experiment exists around the idea that aliens exist. So if aliens exist, number one, what do you think they would look like and why? Number two, why haven't we found them yet? Number three, what do you think would happen if we made contact? And number four, draw your alien from number one. Make sure you include reasons for their characteristics. Are they tall? Are they short? Are they fat? Are they skinny? All these things, make sure you include that in your drawing. Now again, this is a thought experiment around the idea that aliens exist. If you don't believe aliens exist, that's fine, but I'd like you to complete this activity as if you do. Now what I'd like you to do is pause the video and complete this thought experiment. Now before you conclude this lesson, I want you to watch number 4. It takes a look at what's called the Fermi paradox and helps explain why we haven't come across aliens yet. Once you've done that, you'll conclude the Immensity of the Universe lesson.